Today we will discuss determination of tolerance limit and process capability studies. Means what will be the tolerance limit of a product? A process in statistical control means that the control charts for both the mean and range show complete homogeneity, and in such a case a measure of the variation of the individual product, a measure of the variation of the individual product is given by the standard deviation. Once more, a process in statistical control implies that control chart for both the mean and range show completely homogeneity, and in such a case a measure of the variation of the individual product is given by the standard deviation. Standard deviation is the measure of the variability, and this is estimated by r bar upon d2. R small s bar upon c2 from the control data. If mu and sigma, suppose mu and sigma are the process average and process standard deviation respectively, then the limits mu plus minus 3 sigma are called natural tolerance limits. Mu plus minus 3 sigma are called the natural tolerance limits, and the probability of an observation lying outside these limits is 0.0027. This is the probability p q, that is 1 minus p, and it will be equal to 0.0027. The natural tolerance limits are mu plus minus 3 sigma, and width of this standard deviation, that is 3 sigma plus 3 sigma, that is 6 sigma, which is the variability of the process, is known as natural tolerance. 6 sigma is called natural tolerance, and mu plus minus 3 sigma are called natural tolerance limits. If mu and sigma are not known, then in this case we use the estimate of mu and sigma. So mu hat plus minus 3 sigma hat are the estimates of the natural tolerance limit, where mu hat is x bar bar and sigma hat is equal to r bar upon d2, or sigma hat is equal to s bar upon small s bar upon c2. Means if you do not know the value of the mu and sigma, then in this case we use the estimate of mu and sigma. Now it might happen that even though the process is in statistical control, this is the main point, understand. If the process is in statistical control, and as shown by control charts, means you are seeing that in control chart process is in statistical control. The customer may not be satisfied with the product, means you are saying that product is good in all respect, but the customer is not satisfied with the product. Now it is the matter of why such cases arises. The answer is that this happens only when the process does not conform to the specification limits. Okay, this happens only when the process does not conform to specification limits. What is this specification limits? This is the limits which are desired, which are expected by the customer, are fixed by the customer. Okay, for the item, and these specification limits are given in terms of upper and lower tolerance limit. Now, a decision where a process needs adjustment or not. This is the important point. A decision whether a process needs adjustment or not. Can be made by comparing natural tolerance limit and natural specification limits. Means there is anything to be improved, and it may be done by comparing natural tolerance limit and natural specification limits. Okay, now we do compare comparison. Suppose first of all you should consider the given figure, and this is your one line is for x maximum, and in last line is for x minimum, and one dotted line are for UCL, upper control limit, and middle this is there is control line, and LCL, lower control limit. Okay, and this is the natural tolerance smaller than a specified tolerance figure. We suppose that x maximum and x minimum denote the upper specification limits, which is denoted by USL, and lower specification limit denoted by LSL, respectively, for some quality characteristic of a product. Okay, when both these limits, that is USL, upper specification limit, and LSL, lower specification limit, are specified, means known, then a comparison of these limits with the natural tolerance limits may result in one of the following three situations. Means if you when you compare x maximum and x minimum, then following situations may arise. And number one is that natural tolerance is smaller than specified tolerance. It means x maximum minus x minimum is greater than 6 sigma. Okay, in such a case, almost all the manufactured item will conform to specification as long as the process is in statistical control and is centered as in positions given as A, B, or C as shown in figures. If the process is operating under one of these conditions, then X bar may be permitted to go out of control, and provided it does not go too far, means not so far. In other words, the distribution of X bar may be allowed to fluctuate between positions B and C, and this will save the time and money for frequent machine setting and delays due to looking for assignable causes of variations which will not be responsible for unsatisfactory product. Now, second situation may be specification limits coincide with tolerance limits. That means X maximum minus X minimum is equivalent to 6 sigma, means specification limits coincide with the tolerance limit, that is 6d, 6 sigma. This is an ideal situation, and in this case a process in statistical control means the product is meeting with the specifications. And now we consider the third situation. Third situation is that natural tolerance is greater than specified tolerance. That means X maximum minus X minimum is less than 6 sigma. If the natural tolerance are not included within the specification limits, then even with the process in control, even with the process in control and the process average perfectly centered at the specification mean, the production of an appreciable quality of defective items is invertible. Here, a slight shift in the process average will increase the certain percent defective. Means in such a situation, if natural tolerance is greater than the specified tolerance, that means X maximum minus X minimum is less than 6 sigma. In such a situation, a readjustment of the process is advisable with respect to the process average or process dispersions or both. This is very simple. You should read it 2 times, 3 times, and every point will be clear. Okay, that's all of today class. Thank you.